Let's see what you already know. Okay, how about this?
So you have to do dy dx with, you change the letters to, I don't know.
dv/dr.
Why?
Rate of
It's
change.
the one that's with respect, the bottom one.
It's because it's r, not x.
No.
And pi is just a number.
So we do 3 times 4 over 3 equals 4 pi r squared.
Yep. Is that your cat?
Yeah.
What's your cat's name?
Millie.
Millie, yeah. Rate of change. Okay. When the radius is 5 centimeters.
So you sub in 5 for r. 4 pi squared. I got 100 pi.
Yep. Great. If only they were all that easy. Let me see. I'm going to start different one that starts with a diagram. Is this a good one to use? I might start with a flat one. I'll just see. No. Maybe. Yeah. No, I'll come back to that one. Alright. Tricky time. They're all difficult. Okay, let's try this.
So do we have to do dy dx?
Find an expression for h in terms of x for the height.
Like, so wait, do we need to differentiate anything or no?
That's part C.
Should you use the volume equals base times height times length?
Yeah.
So then, and then rearrange it so that h. So you divide b by the base and the length.
Yep. Right. And so, for this question in particular,
H equals 4,000 over x, 2x squared.
well done. Part B.
So it's like the total surface area.
Well done.
So total surface area equals h times x times
No. Or maybe. Go on.
times 2.
Yep.
And then plus 2x squared times 2.
Okay.
And is there another 2x squared for the bottom?
Let me see. The bottom is 2x squared, I believe.
And so the sides.
Uh,
Oh no, that's 2xh.
yeah.
So plus 2xh times 2.
Yes.
So then we get 6hx plus 2x squared.
Mm-hmm.
And then you have to rearrange it to give you 2x squared plus 12,000 over x.
Spot the difference. What's the main difference between what we have and what they have?
H. They don't have it.
They don't have H.
So they worked out the height.
We also worked out the height in terms of x in part A.
So they did. So if you use h equals 4,000 over 2x squared, then so we have 6h. So 4,000 times 6 equals 24,000.
And so you sub 4,000 over 2x squared for h and then work everything out.
So 24,000 over 2x cubed.
No.
24,000x over 12x cubed.
2x squared. 6 is the same as 6 over 1.
Oh. And then what about the x afterwards?
That's the same as x over 1.
Oh, okay. So then plus 2x squared. And then if we simplify that, is 2x squared plus 12,000 over x.
X over x squared, yes. 12,000 over x. Part C.
So is it like dx, dh or something like that?
To find the value of x for which a is a minimum.
So dA over dx. Do we use the one from B?
Yeah.
So 4x plus, no, minus 12,000 x to the minus 2.
Mm-hmm. That's the same as over x squared, whichever you prefer.
Yeah. And then how do we use that to find the minimum?
What do you know about the derivative at a minimum?
Is it equal to 0?
Sure is.
So then now what do we do?
Solve.
How?
How? 4x minus 12,000 over, that should be over x, shouldn't it? Oh, that's right. Yeah, over x squared equals 0. What's difficult about solving this?
It's over x squared
How could you get rid of that?
times by x squared.
Yep.
So we get 4x cubed minus 12,000. So then we get 4x cubed is equal to 12,000. So x cubed is 12,000 over 4, which is 3,000, and then you work out the cubed root of that, and I got 14.4.
So let's say that's roughly 14.4. And what is it to 5 sig fig?
14.422.
Okay. Part D.
Do you do the other way around?
No.
Like, but the minimum of A.
Yeah. So what did we just find?
When the value of x when A is minimum, so do we use that value of x and sub it back into the equation from B?
Yes.
So we have 2 brackets 14.422 squared plus, and I got 1,248.
D 1,248, and that's using 14.422 or answer, is it?
Yeah, no, it's 14 point when it's to 5 significant figures.
Okay. And E.
I don't know how you would show it.
At a minimum, d squared y by dx squared is greater than 0.
Oh, so because it's bigger than 0, then it must be
No,
a minimum.
we found dA by dx.
Yeah. Oh, we need to find the second derivative.
Mm-hmm.
So I can't see the top bit of the writing, but
It's the same thing.
so then we get 4 . plus 24,000 x to the minus 3.
Mm-hmm. Yep.
And then do you set that to 0?
No. We show that that is greater than 0 for this value of x.
So when x equals 14.422.
Yep.
So we sub in squared
Cubed.
cubed.
Won't make any difference at all.
And then I got 12, which is bigger than 0.
12, which is greater than 0, therefore minimum. Yes. So let us recap. Big picture with these. So you're already very good at this, much better than most people. Let's go back to the easy one. I like the easy ones. Okay, so this one, nice and easy. They say find the rate of change of the volume when the radius is 5. So you differentiate, sub in 5, that's your answer. Life is wonderful. Difficult one. They say find the minimum area. Where is it? Find the minimum area. We said that the area was 6hx plus 2x squared. Wonderful. dA by d, oh, hold on. I can't do dA by dx because it's got a h. I can't do dA by dh because it's got an x. It has a mixture of h and x, and so I can't differentiate it. So I need a second equation. We use volume. We make h the subject, and we sub in that, so that instead of having a mix of h and x, we have just x and x, so just lots of x's. Once we have that, then we can differentiate it. We can do dA by dx because it's just x's. That's the big picture. And then the other stuff is stuff you should already know, young lady. Let's say at a minimum, the derivative is 0. And to prove that it's a minimum, the double derivative is greater than 0. But big picture, if you can, just differentiate and do all the stuff. If you can't, because it's got two variables, use two equations, make one the subject, sub it in so that you just have one variable, then you can differentiate. Any questions there?
No.
Told you it was tricky. Let's see. This one. Do we do circles yet? Not just yet. Nah. Exam question time. Cell on there. Yep. Let me think about this. How difficult do I make your life? Okay. One sec. Yep. Alright. Let's make it difficult.
So the volume would be but we don't have the other sides.
So what would be the height?
I don't know. X.
So that's going to be x. I'm going to call this L for length.
Okay.
So how do we do this?
Volume equals x squared times L.
Mm-hmm.
Now what?
They give you the area.
So area equals 2x squared plus 4xl or lx.
Let me see. How'd you get 4?
Because the sides and the top and bottom. 3. Okay. And then do you do simultaneous equations?
Kind of.
So we don't have what the volume actually is.
No, we don't. What do we have?
The area.
So what do we do with that?
608. Do you do x squared? No. L is equal to v over x squared.
You could. We're trying to find v. We're trying to show that v is equal to this. What's different between their v and our v?
L.
Yep.
So how do we get rid of L?
You would make L the subject in the other equation.
Oh. It's 608 minus 2x squared divided by 3x, maybe,
Yep.
is equal to L.
Mm-hmm.
So then you would do v equals x squared and then sub that in for L and then expand it. We get
I expanded it in my head and I got what they told me I would get. What do you think? Examiner can't tell the examiner can't tell the difference. I pinky promise I did it in my head. Okay, B.
So if it was a minimum, it would be equal to 0. But it's not a minimum.
What would be at a maximum? What is equal to 0?
something like dy dx.
Yep. In this case, it's not y equals.
dv dx.
Yep.
And then 600.
So classically, they wrote this question in a weird way. I would try it like that.
So we get 608 over 3 minus 2x squared.
Mm-hmm.
So now do we set that equal to 0?
Mm-hmm.
I thought that was for the minimum.
You. Keelan. At a minimum. Yeah. Quadratic.
Yeah.
Negative gradient. Positive gradient. What number is in between a minus and a plus?
0.
If it went from being negative to positive, in the middle it must have been 0.
Yeah.
This
The
one.
same.
The same thing. At a minimum, at a maximum, gradient is 0. Chicken does, man.
So then 608 over 3 equals 2x squared.
Mm-hmm.
608 over 3 divided by 2 gives us 304 over 3. And then we square root that.
Sure.
I got 10.1.
5 sig fig?
10.066.
Sounds good to me. Shift, solve. Okay. Oh, one decimal place. Yeah. Okay. Doesn't matter. And question C.
Do we have to do the second derivative?
Yep.
So minus 4x. And if you sub in 10.1, then you get minus 40.4. So, which is less than 0, so therefore it's a maximum.
Yeah, minus 4 times 10.1 is less than 0, therefore it's a maximum. Great. Same shizzle, different dizzle. This one, so exam questions, looks like they don't help you with this L bit. So I just called it L. They gave us the area, and so we needed the volume, and so I made L the subject in the other equation and subbed it into the volume equation, because the difference was our volume equation was x squared L, their volume equation was just x, and so we had to eliminate it using the other one. Any questions about that?
No.
Okay. That was straight line stuff. Exact same idea. Literally exact same idea. This one is the same, just with no diagram to help you. It's exactly the same. Let's do curved line stuff, but it's totally the same idea.
Okay. is the formula like 4/3 pi r squared?
I think you're thinking of a sphere. Is it 4/3 pi r cubed?
Yeah, maybe.
What is this one for volume?
Yeah.
So pi r squared for the circle on the top.
Oh yeah, times h.
Yep.
Okay. So we do. So we don't have R or H.
We have the surface area. Do you know how to find? Do you know what the formula is for surface area?
No.
Let's see. So we've got two circles. So that's 2 pi r squared, and then plus this bit down here. So this is like roll of toilet paper. If you unroll it, you get a rectangle. It's going to be height times the circumference. That is, circumference is 2 pi r. So 2 pi r times that. Yeah. So 2 pi r squared plus 2 pi r h. Okay.
So and we want to get rid of H.
Mm-hmm.
So from the bottom one, is it?
You tell me.
I think so.
Yes, because we want volume without.
Yeah.
Yep.
Oh yeah. Okay. So to get rid of H, you have to divide it by H.
No. Area is 30,000.
So it's equal to 30,000.
We're not trying to eliminate h from this equation. We're trying to eliminate h from this equation by making h the subject of this one and subbing it in.
So minus 30,000.
Nope. Make h the subject. That means you're trying to make it h equals.
Yeah, but you want to get H away from that, so don't you divide it by H?
Life's gonna be much harder if you have 1 over h or something like that. You want just h equals.
Divide the other thing, 2 pi r.
Yeah. Make your life easy. Subtracting is easier than dividing. Do that first.
So 2 pi r h equals 30,000 minus 2 pi r squared.
Mm-hmm.
And then divide both sides by 2 pi r.
Yep.
So you get h equals 30,000 minus r.
One, two. No. You don't get too clever. 30,000 minus 2 pi r squared all over 2 pi r.
Yeah.
Yep. This has a plus or minus in between, so you'd have to be able to divide both on the top by r or pi.
What do you mean?
Is this what you said?
Yeah.
Okay, that's grand then. Okay, what's next?
We divide it by 2, simplify it.
Sure.
So 15,000 minus pi r over 2 pi.
Okay, you are getting too clever. That's what I just said you don't do. So they're all divisible by 2, all three of them. So they can all be divided by 2. Because it's like factorizing out 2. It has a plus or minus in the middle. So all three don't have r, so you can't take out r. All three don't have pi, so you can't take out pi.
Yeah,
But you just did this. Is that right? You said pi r over pi?
Yeah, but I don't think I meant to. I think I just forgot to say it.
I don't believe that for a second. Okay, what's next?
Now what?
You tell me. We made h the subject. We are trying to show that the volume is this.
So we sub that h into v equals pi r squared h.
Yep.
So pi r squared and then sub in h.
Yep.
And then expand that.
What do you think it's going to expand to?
15,000 r minus pi r cubed.
Yep. The examiner doesn't know that I didn't do that in my head. So I still get full marks. And B.
So we have to differentiate.
Mm-hmm.
So if we do so just 15,000
No.
minus y.
Are you doing dv by dr?
Yeah, from part A.
Oh, I wrote it down wrong. Sorry. Yep, 15,000.
And then minus 3 pi r squared.
Yep.
But we don't have a value. Do we have
Maximum.
Equals 0.
Mm-hmm.
And then, so 15,000 equals 3 pi r squared.
Mm-hmm.
So 15,000 divided by 3 equals 5,000. So 5,000 equals pi r squared. Then 5,000 divided by pi equals 1,591. And then, so r is the square root of that, which is 39.894.
Great.
And then we find the second derivative.
No. that would prove that it's a maximum. What did we just find?
We need to sub in that value into the differentiation. So 15,000 minus 3 pi 39
Answer squared.
answer squared.
Did you get exactly 0?
Yeah.
So you've just checked your answer, and your answer is correct. So the maximum volume is when the radius is 39.894.
Yeah.
So when the radius is 39.894, we get the maximum volume. What is that maximum volume?
If we sub in R to V equals 15,000 R.
Correct.
So 15,000 minus pi 39.8 cubed. Did I type something in wrong? I got a minus number.
15,000 times by the answer. Did you times it by 39.894?
Oh, I didn't for the first bit. Okay, now I got a positive number.
This big one?
Yeah, that one.
Okay, and so let's just check that. There, yes. And so 39, nearly 400,000. There it is. There. Did I cut off a part C or something? Oh, and show that your value is a maximum. How do you show it's a maximum?
The second derivative.
Yep. Yeah. And
Minus
I think
6 pi r.
Yeah. You'd sub in your value into there.
Yeah, and see if it's bigger or less than 0.
What will it be?
Less than 0.
Yeah. Therefore, it's a maximum. Great. So same exact idea, except now it's got circles. Volume is one equation. Area is a different equation. We want the volume, and so we make the second variable the subject of the second equation and sub it into the first equation, so that instead of having two variables we have just one, just like simultaneous equations by substitution. And then you do all your differentiation and stuff. Any questions about that?
No.
And this bit is just rearranging formulae. So they do this with all sorts of shapes and sizes. So here it's a cuboid. Surface area, you find the area of the 6 sides or however many sides there are and add them up. The volume is just base times height times length. Here it's this triangular prism where the area, surface area, would be area of all 5 sides added up. Area of a triangle is a half times base times height, and the volume. So you have to do the area of the triangle, a half times base times height, and then times by the length. It would be the same exact idea. You would make, let's say, L the subject in one of them and sub it into the other to eliminate it. So in this case, you would make L the subject of the volume and then sub that into the area equation to get the area in terms of X only instead of X and L. What you will notice, well, you won't notice it, is this is a 3D shape, so it's volume and area, 3D and 2D. This is 3D or 3D solid, volume and area, which is 3D and 2D, area is 2D. Now let us do at least one like this. It involves a triangle. this time it is 2D, a 2D shape, and so it'll be two equations, 2D and 1D. Instead of being volume and area, it will be area and perimeter, but exact same idea.
So, and y of x, so y,
I would just come up with any equation you can to begin with.
so like the area
Yep.
would be 2xy
Mm-hmm.
plus x squared.
Let me see. So that is 2xy. And this up here. Plus. What shape is it?
Triangles.
And so that's going to be a half times base times height.
But I thought that because there's two triangles, that is just x squared because they're the same.
Did you say x squared or 2x squared?
I think I said x squared.
Okay, I thought you said 2x squared. Yes, so it's a half times base times height. A half times 2 makes 1.
Yeah.
Yep.
So then from that we want to divide by y. Oh no, not yet. 2xy equals minus x squared. So y equals...
No. You're getting ahead of yourself. Okay, so we are trying to find an expression for y in terms of x. We found the area, yeah. What other equation can you find?
the perimeter.
Yep.
No. Can we?
Mm-hmm.
What about the triangle sides?
What about what, sorry?
The triangle.
So
You
you...
use Pythagoras.
Yep.
So x squared plus x squared equals 2x squared.
Mm-hmm.
And then square root of that. 2x. So perimeter is 2x plus 2x plus 2x plus 2y. So
Hold on.
6.
Hold on. How many? So 2x is the base.
Yeah.
I see the 2y.
Yeah.
Where did the rest of the 2x's come from?
The triangle. Right.
That's not part of the perimeter. Perimeter is the outside only.
But the 2x is on the outside.
I see 5 sides. 2x, y, y. This is root 2x squared. This is also...
The root. So plus... Is it plus 2 root 2x squared?
Yes. You can't simplify both of them. That's just square root of 2. So I'll just leave it like that.
So then we need to get rid of y. No. we want to get y by itself.
Yes.
To make y the subject.
Yes, and the reason why I stopped you from making y the subject in the first equation was because I looked ahead to part B and they want us to find the area in terms of x only. Bad book, better real exam question, I imagine, would force you to find y in terms of x of only the second equation, because technically you can find y in terms of, no, technically in terms of a and x, so it's not the worst. Okay, yeah, sorry, continue.
So using the set the p equals 1, it would be 2y equals e minus 2x minus 2 root 2x.
And then
I'm not sure.
So that's 2y equals.
Oh, divide by 2.
Yeah.
So y equals p over 2. P over 2. No.
Go
on. Minus x minus root 2x squared.
Yes, that is y in terms of x and p. We want y in terms of x only. How do we eliminate p?
If we sub in... No. P equals 80.
Yes.
So sub in 80 for p.
Yes. And so p over 2?
40.
Yes. That's part A. How about part B?
So would we sub in y to 2xy plus x squared?
Yep.
So a equals 2x, and then brackets, 40 minus x minus root 2x squared plus x squared, and then we'll expand that. So a equals...
What will it expand to give you?
80x minus x squared brackets 1 plus 2 root 2.
Yeah. And part C.
Calculus.
Mm-hmm.
What does that mean?
Differentiation or integration.
Oh. The exact minimum value of A. Well, how do you know whether to use differentiation or integration?
You tell me. How do you find the minimum area?
From the differentiation.
Yep.
So, dA over dx is equal to 80 minus x squared plus...
1 second. Another way of writing that would be minus and then that number first. And then x squared. Oh, that will be a bit weird. So you know the way differentiation, it's power times coefficient? So that's what you would do. The coefficient is 1 plus 2 root 2.
Okay, so would it become minus 2 plus 4 root 2 x? And then we want to find the maximum, so that's equal to 0. And then we 80 equals 2 plus 4 root 2 x, so x equals 80 divided by 2 plus 4 root 2, which gives us 10.448155.
They said exact value, and so you just leave it as an exact.
I got like minus 40 plus 80 root 2 over 7.
Okay, and if you use a calculator, you don't get an exact value. If I press answer, yeah. So what was the exact answer?
Minus 40 plus 80 root 2 over 7.
80 root 2 all over 7, or just the second bit?
No, all over 7.
All over 7. And if we go here, 40 over 1 plus 2 root 2, that might be your calculator is automatically rationalizing the denominator. Their denominator is irrational.
Yeah.
And so that's fine.
Okay.
That was that. And that was, let me see this one. Yes, part B, you'll notice they got no extra marks for expanding it. See what I mean? So area is 2xy. They subbed that in for y, and then they said that that's their answer. So
okay,
three mark question, and so I'm not just doing that to be cute or whatever. There's no extra marks for it. Yes, so this was a 2D one involving area and perimeter. All the others were 3D involving volume and area, in that case surface area. It's always the same idea, simultaneous equations by substitution. Easy type of question, to find the minimum or maximum, differentiate. Difficult type of question, simultaneous equations by substitution, so that you have only one variable so that you can differentiate. Any questions there?
No.
And so we did the cuboid type, which is popular. We did the cylinder type, which is popular, and the triangle type. And we did 3D and 2D. And if we glance at these, you can see cylinder, 3D, 2D. Yeah, how was that for you?
That was good, thank you.
Any topic in particular you want to do next time?
I'll let you know.
Alright, any questions for me in general?
No.
Alright, well done, Keelan. You did great.
Thank you.
I look forward to chatting again next week.
You too, have a good week.
You too. Goodbye.
Bye.